Working with arithmetic series. So a series is an expression representing the sum of a given sequence. So we have two different types. We have finite and we have infinite. So a finite sequence would be 6, 9, 12, 15, 18, whereas an infinite sequence would be 3, 7, 11, 15, and then it would keep going. So let's take a look at the finite series. A series number saying is the sum. So we would do 6 plus 9 plus 12 plus 15 plus 18, and we would get a number. That would be a finite series. Infinite would be 3 plus 7 plus 11 plus 15, but we would keep adding because our sequence does not end. So let's write and evaluate the series for the given finite sequence. So we have 2 plus 11 plus 20 plus 29 plus 38 plus 47, and that series equals 147. So this one we would have 100 plus 125 plus 150 plus 175 plus 200 plus 225, and that series equals 975. So let's look at the arithmetic series. It's a series whose terms for an arithmetic sequence. So we have a formula. The sum of the finite arithmetic series is S of n, and n still stands for the nth term, and a1 is our first term. And now an equals our last term. Oops. So, without counting, we want to know how many dots are in the triangle. So let's use this formula. S of n equals n divided by 2 times by our first term plus our last term. So, looking at this, we have row 1 down to row 7. So we have 7 terms. So that means our n is 7. So we have 7 terms, 7 rows. We know our first term has 1 dot. So our last term has 13. So it has 13 dots. So if we simplify this, 1 plus 13 is 14. So 7 divided by 2 times by 14. There are 49 dots in this series. Alright, let's take a look and flip over to the back side. Summation notation. This K represents the upper limit. So how many terms you're going to. This n equals represents our lower limit, which is our least value. And then this a sub n, represents our explicit formula that we will use. Alright, so let's use summation notation to write the series 3 plus 6 plus 9 plus so on and so forth for 33 terms. So summation notation, we know there's going to be 33 terms, so that's the upper limit that we're going to go to is 33 terms. We start with n equals 1, so for our first term. So now we have to determine what our explicit formula is going to be. So we're going back to arithmetic sequences that we've worked on. And I know we are adding 3 to every number. So if we go back to arithmetic sequences, remember it was the first term plus what the common difference is times by n minus 1. So we know our first term is 3. We're adding 3 to every term after that. And we know that we have n minus 1. So if we distribute that out, we have a 3 plus 3n minus 3. So to simplify, 3 minus 3 is 0. So we know our explicit formula is 3 times n. Alright, let's look at this example. We have the summation notation where upper limit of 9, our lower limit is 1, and our explicit formula is 5n plus 3. So we want to know how many terms are in the series. Well, since we're starting at term 1 and we're going up to term 9, we know there are 9 terms. So we want to find the first and our last terms in the series. So our first term, I mean, we take this explicit formula, but plug in our first term, which is a 1 plus 3. So 5 times 1 is 5 plus 3. So our first term is 8. So our last term, using this, our last term is the upper limit of 9. So 5 times 9 plus 3. 5 times 9 is 45, add 3, 48. So we want to evaluate the series. So first, we're going to talk, just to get and see and a feel for what series mean, we are going to do the long-handed. So for our first term, we know it's 5 times 1 plus 3. Then we're going to add that to the second term, which would have been 5 times 2 plus 3, plus the third, and the fourth, and the fifth term, the sixth, seeing how it's already starting to be long-winded, 8, oop, running out of room, and the ninth term. This is what evaluating the series does. You're looking at each of your 9 terms and you're adding them together. So for instance, this is 8. Then we have 13, 18, 23, 28, 33, 38, 43, 48. So those are our 9 terms found by doing each of these individually. If we add those all together, we get 252. So when we're doing the series, we're taking each term and we are adding them together. So let's use our formula that we know. We know that we have 9 terms. So we have 9 divided by 2. We know our first term was 8 and our last term was 48. So if I take a look at this S series of the 9 terms, it's 9 divided by 2 times by 8 plus 48, which is 56. When you do 9 halves times by 56, we get 252. So the long way versus the formula. Just always remember to get this formula, that means we are adding each one. Alright, let's look at one more. So how many terms are in this series? We have an upper limit of 16, but we don't start until 2. So that means we have 15 terms because we skipped over 1 and we went right to 2. So there's 15 terms. So to find the first term, since our first term is that 2, we would do 2 squared minus 10, and that would equal negative 6. 4 minus 10 is negative 6. So then our last term is 16, so 16 squared minus 10, and 16 squared minus 10 is 246. So we want to evaluate the series. So we could go through and write down all 15 terms, solve them to find what they are, and then add them together. Let's use our shortcut using the formula. So we want to find the series of 15 terms. So it's 15 divided by 2. Our first term is negative 6, and our last term is 246. So if we add together negative 6 plus 246, we get 240. So when we do 15 divided by 2 times by 240, we get 1,800.